Thank you so much for that introduction. I'm Carrie Sundra, and yes, I'm about to talk to you about the hells of putting a battery in something that you sell. So I make things and I try to sell them, and sometimes I'm even successful at selling them. I make things for electronics, I make things for yarn, I make things that plug into walls, and I make soldering kits that take CR2032 coin cell batteries. And I'm working on a few new things that are going to take, one is going to take a small lithium polymer battery, and another thing is going to probably be powered by an 18650, maybe with like a custom packaging and charge circuit on it. So I've been thinking a lot about battery choice this year and all the pros and cons of different types of batteries. And so that's why I created this talk, so that I could try to share that thought process with you. Okay, disclaimer. I am not a lawyer. This is not legal advice. This is not even business advice. This is not advice at all. It's not bad advice. It's not good advice. Even if I say my advice is, it's not advice. Okay, all right, cool. And the thing is, whenever you're talking about something that has to do with child safety, it is a very emotional topic, and there are a lot of knee-jerk reactions, and I just want to say that I do not hate children. I like children. I want there to be children in this world. I want them to be happy, and I want them to thrive. But there are a lot of frustrations about regulations being hard to deal with as a small business, as somebody doing niche things, not having a lot of budgetary overhead for, hiring a compliance officer. If you do have budgetary overhead, you should hire a compliance officer or a consultant, absolutely. Okay, this is actually the only piece of advice in this whole thing. My advice is, if you can get away with powering your thing from a USB-C port, you should do it. Because then the battery is somebody else's problem to worry about, or the wall wart, or whatever. If you can just stick a USB-C connector on it, you should do that. But also, don't forget those two little CC resistors. I swear there are resistors in that photo. That just makes it so that the more modern power supplies that have a USB-C output will actually power your device. Otherwise, they're expecting voltages on those lines. If you don't have those resistors on your device, they will not actually output power to your device, and you'll only be able to power your things from sort of like old school USB-A connector power supplies. Okay, so for the rest of us, if you cannot use a USB-C connector on your thing, then basically, you have a choice of what is your pain tolerance when you're looking at batteries, and so, and it just depends upon where your pain points are. So I'm going to start with coin cells, and I did actually put some numbers in that first row because otherwise my nice infographic was feeling a little bit too hand-wavy. Specifically, when we talk about CR2032s, like there is a really good reason that coin cells are so popular. It's because they actually pack quite a bit of energy into that small little form factor, right? And the form factor is super thin. It's only 3.2 millimeters tall, so you can use it for like really thin, flat products. Yeah, it only has 250 milliamp hours, and you can't pull a lot of current out of it at any given time. But if you only need a little bit of current and you want your device to last long, like maybe a watch or something like that, coin cells are a really great choice for that. But the capacity of the chemistry overall, it only gets like 1 lightning bolt out of 3 lightning bolts, because you just can't get a lot. You can't get like high capacity coin cells really. They do get a little bit bigger than a CR2032. But they're not very common, and they get to be more expensive. They're also like really cheap because they're used so much, right? And in terms of safety, like on the boom scale, they only get 1 boom. Super safe boom-wise, right? It's really hard to make them overheat. It's hard to make them explode. They have that nice steel case to them. You can't like poke a pair of scissors through them. They're a really nice solution, except except when it comes to toddlers. So the problem with coin cell batteries is that if a toddler swallows a coin cell battery, even though it can't discharge at a very high rate, it can discharge at a high enough rate that it will burn through your esophagus or stomach, because like it turns out that we're full of conductive juices. So yeah, very unfortunate. And it can happen within like 2 hours, so it's a very, very small window, and they can be deadly. And because we don't like things that are deadly to kids, again, love kids are great, but they get a 3 pain in the ass factor in terms of regulations on my 1 to 3 pain in the ass factor scale. And you know, Australia and Europe have enacted coin cell regulations a few years ago, and you know, as the US, we're lagging a little bit, but now we have them, and they were really only enacted in the past year, so that's why I'm kind of doing this talk, because a lot of people are like, oh no, now what do I have to do? So the next chemistry, we have, you know, your higher power lithiums, your lithium polymers, your lithium ions. They're not a bad solution for a lot of things, but it turns out that in really small form factors, they're actually not as energy dense as a coin cell, which is like kind of crazy and hard to believe, because we think about like 18650s being these powerhouses, and they are. But if you're talking about something in a very, very small form factor, you know, a 250 milliamp hour LiPo cell is about 3 times the volume. It's like about 3,000 millimeters cubed versus 1,000 millimeters cubed. So if you're looking to keep something small, and this is also like with a little protection circuit on it and stuff like that, but if you're looking to keep something small, they are still, you know, quite a bit bigger. But if you have a device where you need more than 250 milliamp hours, or you need to like pull an amp out of it or something like that, then like, you know, you're gonna go with a larger lithium ion. That chemistry has has more capacity and more options. And you know, they're not very expensive either, because they're pretty ubiquitous nowadays, used for tons of things. However, on the safety scale, they get 3 booms. Because they are finicky, right? They are like delicate little batteries. You have to make sure that you don't overcharge them. You have to make sure that you're not over discharging them. You have to make sure, you know, that you're not pulling too much current out of them too fast. You have to make sure that you're not charging them too fast. They're little sensitive batteries. So, you know, there's a lot of external circuitry and considerations that you have to do in order to use them effectively. And also, in the case of lithium polymers that have that nice like little flat form factors with the foil, you also have to have some physical protections so that you can't crush the cells or like stick something sharp through the cells, because then it doesn't matter what kind of protection circuitry you have on it, you're just, you know, that thing's just going to catch on fire. So because of all of those, they get like a two deadlies on my 1 to 3 deadly scale. And that's mostly because of all of the different transportation hazards. You know, if something goes wrong while they're being transported, that can be a danger to the people who are doing the transportation. And so they get a 2 pain in the ass on the regulatory pain in the ass scale. So supercapacitors are very, very cool, but they are also not very energy dense. They're pretty big. If you haven't seen a supercapacitor, they look like large aluminum electrolytic capacitors. They're like these little cylindrical tubes, and you know, one that has the same, not the same form factor, but the same volume as a coin cell, you know, 100 or 1,000 millimeters cubed, it has like less than 1/10 of the capacity of a coin cell, only maybe 17 milliamp hours. So if you have something that is super duper low power, and also you're not super cost sensitive, then these can be a really, really good solution. But just you have to know these things about supercapacitors. In terms of cost, like a coin cell battery might cost you like 20 cents. A small lithium polymer battery might cost you like $1 or $1.50, depending upon what kind of protection circuitry it has on it. A supercapacitor, that might cost you like around $5. So it starts to get kind of expensive. And in terms of the chemistry overall, like giant supercapacitors do exist, but you're probably not going to use them on something like portable or wearable or something like that. But they are pretty safe. Only 2 booms on the boom scale. They still can go boom. You can like overcharge them and make them explode, and they have those little vented lids and stuff. But they are a little less finicky than LiPos and lithium ions. You can pull a lot of current out of them really quickly, and they don't really care. You can also charge them with a high current really quickly, and they don't really care. So they're slightly easier to deal with. And so they also are pretty safe. You're also not really in danger of swallowing a charged supercapacitor because they're usually soldered into things. So they only get like a 1 pain in the ass on the pain in the ass regulatory scale. And then alkalins, are pretty common. They have good capacity. The bummer about them is that they only are 1.5 volts each, and they're big. So if you have something where you absolutely need 3 volts in your system, you're using a larger chemistry, and you need 2 of them. And so that's why they only get a 2 on the capacity of the chemistry, because it's kind of qualified by them being very, very large. Now, if you have something that can run off of 1.5 volts, that's cool. That might actually be very, very compelling. Or if you just have a lot of space. I mean, they're commonly available. They're not very expensive. And in terms of safety, like the worst thing that they can do is like leak some acid after a while. So, they're not really very lethal, and there's hardly no regulations on them. So this is sort of the thing that you have to hold in your head when you're thinking about designing something with coin cells. And I'll take questions at the end. So I'm about to go into some of the regulations, and I would just like to say that like all the links and the slides to in a couple of hours will be at this GitHub repo. All the links are on there now. But that's like links to all of the text of all the regulations, sample reports, all sorts of stuff. So, and I'll flip this up again at the end of the talk too. Okay, so coin cell battery regulations in the USA. You very quickly can get lost in a morass of all of these numbers when you start looking up information. So I'm going to kind of break it down into the different steps. So there was the actual law that was passed by Congress. That's called Reese's Law. It also goes by all of those other names and numbers. But basically, Congress said that, like, okay, swallowable batteries are in fact dangerous. And the CPSC needs to come up with regulations to deal with this by like whatever date. And the CPSC is the Consumer Product Safety Commission. They defined coin cell batteries as any battery with a diameter greater than its height. But then there's also sort of this clause that's like, and whatever we think might be an ingestion hazard. So to my knowledge, I haven't seen anything else defined as an ingestion hazard that's not a coin cell battery, but there is kind of that catch-all where other things could potentially be covered by this in the future. So the CPSC was like, okay, ball is in our court now, and they came up with this 16 CFR Part 1263. And that's the actual text of the coin cell regulation. And it's really interesting because most of what you'll see there are labeling requirements. There are pages and pages of labeling requirements there. And then when it comes to the actual physical design of the battery container, they're just like, hey, UL already has this standard 4200A. It's like this voluntary thing, but we're just going to adopt it, make it law. They've already done the work for us. Cool, we're done. And this is really annoying because then when you go to UL's website, you're like, oh, if I want to read the standard, it's $400 to $1,000, depending upon if you want like some DRM'd up PDF or an actual physical printed copy, or of course a subscription service, because who doesn't love a subscription service, right? So it's kind of crazy. And this is the point as a small manufacturer where you start to get like really cranky about all this stuff, and you have to reassure people that you don't hate children, right? You don't hate children. You want to do what's best. So this brings us to the UL's perfectly legitimate business model. And so like this is actually the entirety of that CFR 1263 that applies to the physical like containment of a battery. This is the entire text that the CPSC put together on it. And so they're just like, yep, UL 4200A, and you can maybe, call them or like mail them a letter and get this standard for free, or you can go to this secret link that we're just going to give you here that like I haven't found anywhere else on the internet. And so you're like, okay, cool. And like at this point in time, like UL is Underwriters Laboratory. They are a test lab. They are in the business of making money by testing things. So the more things that they have to test and the more complicated those tests have to be, the more money they will make, right? Okay, so you click the super secret link, right? And then, of course, it doesn't just take you to the standard, it takes you to a page where you actually have to register for an account in order to read this thing that is actually like codified into law. Okay. So you register, your mom verifies your email address. And then you get to the welcome page. Welcome to UL's repository of standards that were once voluntary and now have been like codified into law that we sort of have to give you for free. So maybe it'll be a read-only PDF, maybe it'll be a crappily formatted HTML page, but also it might not be the latest, it might be old, that's fine. Sweet, okay, cool. And you get to the actual HTML thing that is UL 4200A. And you're like, okay, cool. Well, I wonder how bad this will be if I print it out. Nope, we don't allow you to do that. You can't press the control key. Okay, I guess highlighting and control C is out. Well, what if I highlight and right click? Nope, no right clicking either. We don't want you to do that. And I'm just saying, man, if some enterprising hacker ruined their day sometime by making all of their stuff publicly accessible in a format that you could download or print, oh, I wouldn't cry any tears about that. Just if anybody needed anything to do, But the good thing is that the way these test labs do things, they just like pretty much copy the entire section of the UL text into a table, which they then put checkboxes by as your device like passes each one. So if you look up somebody else's test report on the internet, you basically get almost the entire UL standard. And also links to these test reports and all of the stuff on that GitHub repo. Okay, so what do we need to do? Okay, okay, we can't allow anything to be touched by test probe 11. What is test probe 11? So you look up test probe 11 and you're like, it is a rigid test finger. And now all of a sudden, battery compliance is sounding more interesting. Okay. But you look this up and basically what this means is this rigid test finger, is this rigid test finger, can't touch this. So yeah, it's really interesting, and they specifically say that we're not talking about being able to push it or put any force on it. This rigid test finger cannot touch a battery in a device. There are no safety hazards associated with a human just being able to touch a coin cell battery. I'm sure we've all done it, right? So that's really interesting. And like the specific part about this that really annoys me is that it's obvious that this test standard was written from the perspective of a battery like having an enclosure. And a lot of us make circuit boards where the battery is just there. The thing about it is that this can still be done pretty darn safely. This is one of our soldering kits. We first started out with a different style of holder, but I changed to the style of holder that has what I affectionately call the butt catcher. So it's a little tab just below that plus that like sticks into the board, and what that prevents you from doing is taking your rigid test finger and pushing the battery out the front. And also, since in this particular implementation, the battery is so far recessed from the edge, it is impossible to get a grip on that battery to pull it out. Like, even if you try the push method, the push down and out method, it just doesn't work. Like, I need a tool in order to remove that battery. I need to like push it with a screwdriver. Like, you can get in the those little angled spaces. And so I can push it with a screwdriver or a popsicle stick or something like that. But, I think that this is a pretty darned safe way of doing things. So more in the UL 4200A. Well, indeed, they say that like, okay, so your battery compartment should need a tool to open it, or two independent simultaneous movements. So, think about like pill bottles where you have to like push down and turn and rotate, that kind of a thing. So, but there's another thing where they're like, oh, but if you use a screw or a fastener, it has to be captive. And I assume this is then because of the swallowing hazard of said fastener, even though I'm sure like number 2 tiny screws that are usually used in these applications probably don't actually pose a choking hazard. But again, I'm not a lawyer, I'm not a medical professional. I'm just somebody who's trying to use common sense and stay in business. So it is interesting that, and I mean, I do know of some products who have passed this testing who would absolutely fail that rigid finger touch test and that don't have captive fasteners. So, if you can find a test lab that will check those boxes for you, then sure, go for it. There's more stuff in 4200A. There's like all the possible ways in which it could be abused. And this is sort of another thing. It's like, if you are making something that is very delicate and fragile and contains a coin cell, even if your device is busted into a million pieces during all of this testing, and there are force standards for all of this, so it's not just like as hard as you can on any of this stuff. But even if your device breaks, the battery still has to remain captive. It still has to not be in a swallowable state. And so this is where I'm just going to remind you that accredited test labs are all over the world. Ones in China will probably be a lot less expensive than ones in the US. And definitely don't give UL your money. Like, geez, they want to charge you for just being able to read this in the first place, right? Okay, so like, yeah, are there some better ways of doing things? Well, I don't know, I think there are. Why isn't there a provision to have a connector certified, right? And obviously it's because, test labs wouldn't make as much money if we all could just use a certified connector and didn't have to give every single one of our devices to a test lab. But like, I feel like that is a very solvable thing. There are places making connectors out there that would absolutely do this and then be able to sell a ton of connectors. It seems like a total win-win situation. Why are there no design guidelines that you would be able to self-certify with existing connectors like the one that I showed you? If you say like, well, it has to be, X millimeters off from the edge of the board, it has to have the butt catcher, this and that, the other thing, like, it seems like there could be solutions that way too that, would not endanger children and also not require a lot of expensive testing. And there's also just a scope thing that is difficult to deal with. Like, why are there no distinctions between businesses selling a few hundred of things and businesses selling millions of things? But overall, like, yeah, I feel like totally passing the buck to UL and being like, oh, we're just gonna adopt their thing is just like putting the fox in charge of the hen house. Like, the companies that are doing the testing shouldn't be setting the conditions under which you have to do the testing. Like, I feel like there's an inherent conflict of interest there. Okay, so who actually cares about your test report? Who actually wants to see it? So if you want to sell on Amazon, then they will want your test report. They will also want this thing called a declaration of conformity. But this is like a DIY thing, so you just make up some super cool letterhead and you're like, I do solemnly swear that my thing is is absolutely in compliance with CFR, blah, 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 blah. Or you can choose some other voice, whatever. However you want to make your own declaration of conformity is fine. But it is just a self-certified piece of paper that you make up. And so Amazon wants to see those two things. Toy stores are another interesting thing, and in fact, if you make something specifically for kids, you have to comply with totally different rules. There is a different CFR that handles that, and there is a different set of tests. It's the ASTM F963. So this stuff that I just went over really only covers coin cells in consumer devices that aren't meant to be used by kids but might fall into the hands of kids. And then, maybe your investors or insurance might care. That's probably mostly like a cover your ass and due diligence thing, but they might ask to have that as part of a packet before you get some investment. So there is actually one notable exception to Reese's Law in terms of coin cells, and that is specifically for the zinc air chemistry. And my joke is that's because lawmakers got to have those hearing aid batteries, right? But yeah, they are batteries that are typically used in hearing aids. They're sort of like that kind of form factor and size. But I actually had a fair bit of trouble finding out like exactly why are zinc air batteries so safe? And I was only able to sort of find a mention. It's like, oh, it's because zinc air batteries only conduct in the presence of air, and it is assumed that there is not enough air in an esophagus or stomach to actually cause it to conduct. I did not see any references to tests or data from that. I don't hate kids. I am not suggesting that we have toddlers swallow these. I'm just saying that, like, has there been due diligence on that too? I don't know. But shit, that means we have another chemistry that we have to add to our pain tolerance chart, so we're just gonna cover up the, the key there. So zinc air batteries are actually pretty cool. I hadn't looked into them much before, actually, and they have an incredible amount of energy density. They are only 1.5 volts each, so you still have like a little bit of the issue of having to use two, but they're so energy dense that it kind of doesn't matter. 2 zinc air batteries at the same kind of 250 milliamp hour capacity of, a CR2032 only take up, 520 cubic millimeters versus 1,000. So that's pretty impressive. And if you can use one that's like a common hearing aid size, they're pretty cheap because they're pretty ubiquitous now. So yeah, they're also small, dense, the form factor, it's hard for them to go boom, and apparently you can totally eat them and they're fine. The reason that they get 2 pains in the asses on the compliance chart is because, like, good luck convincing Amazon that no, these are the type that are fine. Yeah. So you're still probably going to have some pains in the ass in terms of convincing people that actually no compliance is necessary for your type of coin cell. The other kind of issue with these is that So they actually have these little pull tabs on them that open up little pinholes into the case that let air into the case, so the battery becomes active. But that doesn't really stop. So you can cover them and things like that, but once they're open, they start discharging, and they have basically a pretty high internal discharge rate. So they might only last for 3 months before having to be replaced. So if you have something like a hearing aid that's kind of used all the time, it's on all the time, it's not that big of a deal. But if you have a small device where users are expecting to be able to turn it off and have it sit on a desk for 6 months and then turn it back on and still have it work, they might just get pissed off that their thing is always running out of batteries, right? Okay, so what about those LiPos anyway? So lithium polymer and lithium ions, it's really interesting. In the US, the only regulations are shipping regulations. There are actually no real consumer regulations, legal ones, that you have to follow. So we're just gonna assume that y'all are protecting those coin cells and doing the right kind of charge circuitry, and sure, why not? What's also interesting is that in the US, the only shipping requirements are for air shipments, actually. So ground shipments, you have to do even less. However, in other countries, and to get the CE mark, if you're going to be selling in Europe, the EU does have test requirements that include an entire host of electrical tests as well as physical tests and stuff like that. So, if you are making something that you expect to be able to sell internationally, there are more regulations that you have to comply with. It's just the US that kind of gets a little bit fast and loose with them. But it's the same kind of, abuse tests that we just talked about with the coin cell stuff where, it gets dropped. There's an altitude simulation so that they don't explode an aircraft. And then, who cares about those? You're required to upload a report, a UN 38.3 test report for Amazon sellers. So UN 38.3 is the test standard that basically sets out all of those tests that your batteries have to pass in order to be safe to ship. And it is that UN, it is the United Nations standard. Countries actually got together and said it would be great if, these batteries weren't exploding on us. So the UN 38.3 test series is only required for air shipments in the US, but you still have labeling requirements even for ground shipments. And those labeling requirements are it depends upon if it's just a battery by itself, is it a battery that's contained in a device, how much lithium is actually in that battery, and how much lithium is in the entire package that you're shipping. And I really hope you like flowcharts, because you're gonna be looking at a lot of stuff that looks like that. And it's not hard, they're actually pretty reasonably good flowcharts, even better when they're bigger on your own screen. But so the other thing is that I'm talking about this in terms of lithium ions and lithium polymers, but what else contains lithium? Coin cell batteries. So coin cell batteries are also covered by these shipping regulations, and they're that far right one, the lithium metal batteries. And so yes, you technically do have to label soldering kits and stuff like that with one of the little stickers that kind of looks like that. So, and then, if you have more lithium content, then you might also have to do the sticker that's the passenger aircraft warning and stuff like that. But yeah, that's basically what it looks like. And nobody asks to see a test report before you ship a battery, just to let you know. So just take that information and do what you want with it. So what about supercaps? They're super cool, and you should all go to Sanders' talk at 3 because he's going to talk a lot about supercapacitors and knows a lot more about them than me. But There are no shipping regulations on small ones, and you can charge them with the same lithium-ion chips, same chips that you charge lithium-ion batteries with. A lot of the chemistries are totally compatible, so that makes them pretty easy to handle and put into a device. But again, they're only good for really, really low power products. You got to get really tricky with all of your power saving. And yeah, you can't be too price sensitive because comparatively they are quite a bit more expensive than something like a coin cell or even a tiny LiPo. And so yeah, to summarize, alkalins in terms of regulations, there's really nothing. It's a bummer that they're so big and that they're only 1.5 volts each, and that you'll typically need 2 or maybe even 3 or 4 in order to power your device. And then zinc air, again, like no real regulations on those. And if you can use a hearing aid battery, and if it's something where it's kind of expected to be continuously on, then they could be a really, really, really good choice. But if not, if you expect to be able to turn it off and really have it fully off, the self-discharge is a little bit of a bummer. Okay, so where does this leave somebody if they've already designed a whole bunch of kits to take coin cells? Well, I've been shoving USB into places meant for coin cells lately. And this one on the right is something that I designed specifically to basically not have to deal with coin cell battery regulations. So that is a mini board. It just has like a little 3.3 volt LDO on it. It has a 250 milliamp maximum current output and a 10 ohm resistor in line, so it sort of behaves like a coin cell a little bit. So if you hook it directly up to a battery or to an LED without a resistor in line, it won't blow it up. So yeah, I designed that so that I could have a kit that I could sell. I could use all of these boards that I already had made and not have to worry about the regulations. Because if I'm not shipping it with a coin cell battery holder, then it's not designed to use a coin cell battery, and therefore, no regulations. And it is important to note that, even though the text of Reese's law says that it covers anything containing coin cell batteries, the CPSC, when they did their interpretation and their actual regulations, they're like, okay, we are interpreting that to mean anything designed to use a coin cell battery. So it doesn't matter if you're like shipping your thing without a battery in it, if it can actually hold a coin cell battery, it's subject to the regulations. And then this one on the left is something that I actually built a while ago for making displays of our soldering kits and powering them up. And you can actually see that one in action. I have like a little display that's over across the way with all of these lovely soldering kits on them. But that one's called the Coin Cell Power Board. The other one's called the Coin Cell Be Gone. And the coin cell power board, it does basically the same thing, but it allows you to switch between the 5 volts from the USB and the 3 volts from the USB to be output to those pads. And that's basically because some kits use like 2 stacked 2016s instead of a 2032, just to get a little bit of extra voltage. But this does not get around the regulations, because while it replaces a coin cell battery, it doesn't make the kit suddenly not designed to use a coin cell, right? Because you can take that out, you could slide a coin cell in. So it doesn't really solve that problem, but it is an alternative to potentially replace a coin cell with USB in something that was designed to hold a coin cell. There is a little bit of a funny story about that. So this whole Amazon selling thing has been an experiment gone horribly, horribly wrong. It's a huge pain in the ass. I don't recommend it, and I'm trying to decide right now whether I persevere and just go deep in with sunk cost fallacy, or whether I just like cut it off. But I was like, oh, these coin cell power boards could be something really cool to sell on Amazon, right? Because with this whole thing coming up, people trying to get away from coin cells, maybe they would want to buy this so that they could not use a coin cell in their thing. And so I created the listing, and I should note that there is absolutely no way to create a listing for that board without using the words coin cell or CR 2032. Like, I just can't describe what it does without telling you that, right? And so I create the listing is approved, I send some stuff to Amazon, and like 2 weeks later, as it's getting checked in, compliance sends me a nasty gram, and like my listing is put on hold. And they're like, we need to see your declaration of conformity and your UL 4200A report. And I'm like, oh, okay, I understand why this could be confusing, but like, this doesn't actually take a coin cell battery, this replaces a coin cell battery. Like, you can't actually use a coin cell battery with it. And 5 different representatives later, all Indian customer support, yeah, I didn't get anywhere with that. So it was a huge, frustrating thing. What I ended up doing was being like, okay, fine. You want to see my declaration of conformity? I'll show you my declaration of conformity. So I made my declaration of conformity, and then I tried to upload it, and it's like, no, you have to upload a UL 4208 test report too. And I'm like, for fuck's sake, okay, fine. And so I made something else up on Alpenglow letterhead, and it was just a very official statement that it was like, it has been determined that since this does not in fact contain a coin cell, it is not subject to UL 4200A. Sincerely, Carrie Sundra. And a couple days later, my listing was suddenly, I get a message. It doesn't say that it was approved or denied. It just says that your support ticket has been closed. I'm like, okay. And so exactly, I'm like, what's going on? And so I look, and my listing was active, and all of my inventory was marked as defective. And then there's a whole nother story, and this whole story will take several beers. I'm just telling you, and many hours to tell. But like, I'm still in the middle of this. Like, I was basically told that I had to request all of my inventory back, confirm that it wasn't defective, and then send it back to them. And of course, they've charged me hundreds of dollars to do that. My inventory counts aren't right. Like, they didn't send me back all the stuff that I sent to them. I had to make several requests because their system sucks. It's just been a total nightmare. And yeah. And like, what's even worse about all of this is that you're like, wait, fucking what? Like, all of this is on Amazon, right? And you're like, how can these possibly be compliant, right? And so, you can say maybe those middle ones are compliant because they're not consumer products. They're like they're connectors, they're boards meant for use in something else. But like, we all know that those LED controllers have a CR 2032 in them, and just that little tray that pulls out. Conveniently, they don't say that anywhere in the listing. They like say the word battery once, right? And like, this is a rechargeable coin cell battery charger. You just stick the coin cells in and take, so, and I mean, how do you make something like that and still be compliant, right? Like how, so there are definitely things that were not thought about. So it just, this is like kind of where I'm left with all of this. And I'll leave you with like one more story, which is perhaps the most USA thing I have ever read in my life, which is that there was a recall earlier this year because of coin cell battery compliance, and it was a recall on gun sites. So, the real danger of guns, of leaving your toddler unattended with your firearm, is that the gun site might have a non-compliant coin cell battery cover. Yeah. So, it was a Sig Sauer that had that recall, if you want to look it up. But again, all the links to all of the very boring documents that I have referenced in this talk are there, plus just more auxiliary stuff. The UN 38.3 flowcharts, USPS and UPS all have like slightly different flowcharts, so those are linked there too. The slides will be up there later today. And thank you so much. These are, yeah.